Yeah, welcome back everybody. We're going to continue today with the 2017 Further Math past questions. The last one we did was number 10, so we go straight to the next one, which is number 11. How many ways can 6 students be seated around a circular table? The number of ways of arranging objects around arranging things around a circular object is given by n minus 1 factorial. So the number of ways 6 students can be seated around a circular table is going to be 6 minus 1 factorial, and that's 5 factorial, which is 5 times 4 times 3 times 2 times 1, and that's 120. So the correct option is D. Straight we go to number 12. If the product of these two matrices, this one has elements 5, 4, is equal to K times the matrix which has elements 17.5 and 40.0. Find the value of K. Okay, what we do is simply multiply first of all the matrices on the left hand side. So we multiply this row by this column, and that will be 2 times 5, which is 10, plus 1 times 4, which is 4. And now we multiply the second row by this column, and that will be 4 times 5, which is 20, plus 3 times 4, which is 12, equals, here we multiply each of the elements of the matrix by K, and that means 17.5K, and this will be 40K. Now this matrix on the left hand side will be 14. We have elements 14, 32, and that will be equal to 17.5K, and the second element here will be 40K. Now this simply means 17.5K equals 14 and 40K equals 32. We can compare the elements of the two matrices, the corresponding elements of the two matrices. So we can use either of the two equations to solve for K. We can either say 17.5K equals 14 or 40K equals 32 to find the value of K. So I'm using the second one, which says 40K equals 32. And I want to divide both sides by 40 to get K. And that simply means K equals 0.8. And the correct option is C, 0.80. That's the same as 0.8. Number 13, express cos 150 degrees in surd form. Cos 150 degrees can be written as the cosine of the sum of 90 degrees and 60 degrees. And that simply means cos 90 degrees cos 60 degrees minus sine 90 degrees sine 60 degrees. We know that cos A plus B is equal to cos A cos B minus sine A sine B, and that's why cos 90 plus 60 is equal to cos 90 cos 60 minus sine 90 sine 60. And this simply means cos 90 is 0. That means all of this is 0. So that's 0 minus sine 90 is 1 times sine 60, which is root 3 over 2. And that simply means 0 minus root 3 over 2, which is root 3 all over 2. So the correct option is 0 minus root 3 over 2 is minus root 3 over 2. So the correct option is B, which is minus root 3 over 2. Now the next one, which is number 14, is a straight line parallel to 2x plus 3y equals 6 passes through the point minus 1, 2. Find the equation of the line. Let this be the line. This is the line that's parallel to 2x plus 3y equals 6. It passes through a point which has coordinates minus 1, 2. And that line is parallel to this line. The equation of this line is 2x plus 3y equals 6. If two lines are parallel, that means their gradients are equal. So if this one is m1 and this is m2, the gradient of the first line is m1 and that of the second line is m2. m1 will be equal to m2. I can find m2 from the equation of the line, and I do that by making y the subject of the formula. So that means 3y equals 6 minus 2x. when I divide through by 3, I'm going to have y equals 2 minus 2 over 3x. And when you write the equation of a straight line in this form, where y is the subject of the formula, the coefficient of x is a gradient, of that line. So that means m2 equals minus 2 over 3. And therefore, m1 will also be equal to minus 2 over 3 because the two lines are parallel, which means their gradients are equal. Now, the equation of the first line, which passes through the point minus 1, 2, is given by this formula: y minus y1 equals m into x minus x1, where m here is the same as m1, and this is the point through which the line passes. That means x1 is minus 1 and y1 is 2. So I'm going to say y minus 2 equals minus 2 over 3 into bracket x minus x1, which is minus 1. And that simply means y minus 2 equals minus 2 over 3 into bracket x plus 1. If I multiply through by 3 to clear the fraction, I'm going to get 3y minus 6 equals minus 2 into bracket x plus 1. And that simply means 3y minus 6 equals minus 2x minus 2, which is 3y. I'm bringing minus 2x to the left hand side, and it will become plus 2x equals, now I'm taking minus 6 to the right hand side, and it will become plus 6. So that means 3y plus 2x equals minus 2 plus 6 is 4. Therefore, the equation of a line which is parallel to 2x plus 3y equals 6 is 3y plus 2x equals 4. And the correct option is D. Yeah, they wrote it as 2x plus 3y equals 4, which is the same as 3y plus 2x equals 4. So the correct option is D. And straight we go to the next. The next one is number 15. Alpha and beta are the roots of the equation 2x squared minus 3x plus 4 equals 0. Use this information to answer questions 15 and 16. Question 15 says the equation is 2x squared minus 3x plus 4 equals 0. And we want to find alpha plus beta. Here, a is the coefficient of x squared. A is the coefficient of x squared, which is 2. B is the coefficient of x, which is minus 3. And c is the constant, which is 4. So alpha plus beta, which is given by minus b over a. Alpha plus beta is minus b over a, and that simply means minus 3 over 2, which is simply 3 all over 2. And the correct option is C. We go straight to the next, which is number 16. Find alpha over beta plus beta over alpha. If we add those fractions, the LCM is going to be alpha beta. Alpha beta divided by beta is alpha times alpha, that's alpha squared, plus alpha beta divided by alpha is beta times beta, that's beta squared. And that simply means alpha squared plus beta squared over alpha beta. Alpha squared plus beta squared is the same as alpha plus beta all squared minus 2 alpha beta all over alpha beta. Now, how did I get alpha plus beta all squared minus 2 alpha beta for alpha squared plus beta squared? If I do this, if I square the sum of alpha and beta, we'll get alpha squared plus 2 alpha beta plus beta squared. So if you make alpha squared plus beta squared the subject of this equation, that means you have to bring minus 2 alpha beta to the left hand side, and you're going to have alpha plus beta all squared minus 2 alpha beta equals alpha squared plus beta squared. So that's how to get the identity for alpha squared plus beta squared. It is the same as alpha plus beta all squared minus 2 alpha beta. Now this simply means alpha plus beta is 3 over 2. That means the square of 3 over 2 minus 2 times, what is alpha beta? Alpha beta is C over A. and we know that C is 4 while A is 2. So 4 over 2, alpha beta equals 4 over 2, which is 2. So minus 2 alpha beta means minus 2 times 2 all over alpha beta, which is 2. We can erase this, and that simply means 9 over 4 minus 4 all over 2, which means minus 7 over 4 divided by 2 means times 1 over 2, and that's minus 7 all over 8. Straight we go, and the correct option is B. That's the option that matches that. Now to the next, which is number 17. If the matrix B has elements 2, 5, 1, 3, find B inverse. That's the inverse of the matrix B. First of all, we need to find the matrix of cofactors of B. Let the matrix of cofactors of B be C. That means C, the cofactor of 2, will have a sign positive here. How do we know what sign it will have? 2 is in the first row and on the first column. I for rows and J for columns. So that means I plus J, which is first row plus first column, equals 2. Whenever I plus J is positive, the sign that will be attached to the cofactor of that element is going to be positive. So the first cofactor will have a positive sign. Now here for 5 is in the first row. That means I plus J in the first row, and the second column I plus J will be 1 plus 2, which is 3. Since it is odd, if I plus J is even, the sign that will be attached to the cofactor of the element will be positive. If I plus J is odd, we assign a negative sign to the cofactor of the element. So this will have a negative sign. Now for this one, it is a second row first column. So I plus J equals 2 plus 1, which is 3. So that's odd. That means its cofactor will have a negative sign attached to it. Now for 3, the cofactor of 3 is in the second row and on the second column. That means I plus J equals 2 plus 2, which is 4. That's even. That means its cofactor will have a positive sign attached to it. Now let's find the cofactors. Let's find the cofactors. For 2, we delete this row and this column, so we're left with 3, and that will be plus 3. For this element, for 5, we delete this column and this row, and we'll be left with 1. That's minus 1. We already put a sign that the cofactor will have. For this one, we delete this column and this row, and we're left with 5. And for 3, what's the cofactor of 3? We delete this column, and this row, and we'll be left with 2. So this is the matrix of cofactors of B. It has elements plus 3, minus 1, and plus 2. Yeah, whether I put plus or not, it doesn't really matter, but let me leave it that way. So the adjoint of B is therefore, let me rearrange this way, minus 1 and plus 2, just for clarity. Now, the adjoint of B is going to be the transpose of the matrix of cofactors of B. That's the transpose of the matrix C. And that's simply interchanging rows and columns. The first row here will become the first column. That will be plus 3 minus 1. Plus 3 is the same as 3, so I can just write 3. And the second row will become the second column, which is minus 5 and plus 2. Plus 2 is the same as 2, so we can just write 2. That's the adjoint of B. Now, the determinant of B is simply 2 times 3 minus 1 times 5. That's 6 minus 5, which is 1. So we can now find the inverse of B. The inverse of B is the same as, is given by the adjoint of B divided by the determinant of B. And that simply means the adjoint of B is this matrix, which has elements 3 minus 5 and minus 1, 2. That simply means this matrix 3 minus 5 and then minus 1, 2 divided by the determinant of B, which is 1. And that simply means the inverse of the matrix B is the same as this matrix with elements 3 minus 5 minus 1, 2. And that's it simply. That might look a bit tricky, but it's simple if you are careful enough to simplify correctly. And the correct option is the option that matches that. That's number 16 or 17. Yeah, that's number 17. So the option that matches that is C. So the correct option is C. Now we go straight to the next, which is, I check that again, 3 minus 5 minus 1, 2. Yeah, the correct option is C. The next one is number 18. Given that sine x equals 15 over 13 and sine y equals 8 over 17, find the value of the cosine of the sum of angles x and y. Let's just sketch a right angle triangles for the two angles. Let this be x. This is a right angle triangle. If this is x and sine x is 5, sine x is not 15 over 13, no. Sine x is 5 over 13 and sine y is 8 over 17. That's correct. That means opposite will be 5 and hypotenuse will be 13. By Pythagoras' theorem, this is going to be 12. Now for the second angle, which is angle y, let this be the right angle triangle and this be angle y. Sine y is 8 over 13. That means opposite is 8 and hypotenuse is 17. Sine y is 8 over 17, not 8 over 13. That means opposite is 8 and hypotenuse is 17. By Pythagoras' theorem, the adjacent will be 15. So how do we now find cos? The cosine of the sum of angles x and y. Cos x plus y is the same as cos x cos y minus sine x sine y, and that's equal to cos x is going to be adjacent over hypotenuse, that's 12 over 13, times cos y, which is also adjacent over hypotenuse, 15 over 17, minus sine x, which is 5 over 13, times sine y, which is 8 over 17. And what does that mean? 12 times 15 is 180. 13 times 17 is 221, minus 5 times 8, which is 40 over 221. And that's simply 140 all over 221. So the correct option is B, which is 140 over 221. Yeah, sorry about that. Now to the next, that was number 18. Now to the next, which is, so the correct option to that is B, 140 over 221. The next one is number 19. A circle with center 4, 5 passes through the y-intercept of the line 5x minus 2y plus 6 equals 0. Find its equation. That means find the equation of the circle. Let this be the circle. The coordinates of the center of the circle are 4, 5, and it passes through the y-intercept of a line whose equation is 5x minus 2y plus 6. Let's say this is the point on that line through which the circle passes. So the y-intercept, let's say this is a y-intercept of the line, through which, and let this be the y-intercept of the line which the circle cuts or crosses or passes through. So if y at the y-intercept x is equal to 0, so we can find that y-intercept by substituting x equals 0 into the equation. By the way, the equation of the line is 5x minus 2y plus 6 equals 0. At the y-intercept, x equals 0. So to find the y-intercept, we just substitute 0 for x. That means 5 times 0 minus 2y plus 6 equals 0. And that simply means this will be 0. Minus 2y will be equal to minus 6. And that means we divide both sides by minus 2 to find y, which means y equals 3. That means the y-intercept is 3. And at that point, x is 0. So the point through which the circle passes has coordinates 0, 3. Now to find the equation of the circle, we need to know its radius. and this is the radius. We can find the radius by simply using the formula for the distance between 2 points. I want to paste a small image of this diagram so that I can see what I'm using to find the radius of a circle. Now r equals square root of x2 minus x1 all squared. That's 4 minus 0 squared plus y2, which is 5, minus y1, which is 3 all squared. And that simply means the square root of 4 squared, 4 minus 0 is 4, plus 4 squared, 5 minus 3 is 2, and the square of that is 2 squared. So that simply means square root of 16 plus 4, which is 20. So r equals root 20. Now we can find the equation of the circle. The equation of the circle is given by x minus a squared plus y minus b squared equals r squared, where ab is the same as the coordinates of the center of the circle. That means a is 4 and b is 5. So the equation of a circle is therefore x minus 4 squared plus y minus 5 squared equals r, which is the square root of 20, and the square of that will be the square of the square root of 20. That simply means x squared minus 8x plus 16. That's what you have if we expand the square of x minus 4 plus y squared minus 10y plus 25. The square of the square root of 20 is 20 equals 20, and that simply means x squared plus y squared minus 8x. I want to make sure I write well. Minus 8x minus 10y plus 16 plus 25 is 41 equals 20. And that simply means x squared plus y squared minus 8x minus 10y plus 41 minus 20 plus 41 minus 20 equals 0. And therefore the equation of the circle is x squared plus y squared minus 8x minus 10y plus 21 equals 0. X squared plus y squared minus 8x minus 10y plus 21 equals 0. Unfortunately, none of these options matches that answer. I think there's a typo in the options, so we can just move on. The correct answer is x squared plus y squared minus 8x minus 10y plus 21 equals 0. Now on to the last one, which is number 20. Given that f of x is equal to 5x squared minus 4x plus 3. Find the coordinates of the point where the gradient is 6. The gradient is simply the derivative of f of x, and that's f prime. So that's 10x minus 4. If they say f of x is simply the same as saying y. So the gradient of f of x is the same as the gradient of the derivative of y. Derivative of f of x is the same as the derivative of y. That means f prime is the same as dy dx, and that's 10x minus 4. Now, if f prime is 6, that simply means 10x minus 4 equals 6. And that means 10x equals 6 plus 4, which means 10x equals 10. And we divide both sides by 10 to get x. And that means x equals 1. Now, that's the value of x where at the point where the gradient is 6. That's the value of the coordinate x where the gradient is 6. Let's find what y will be. If x is 1, that means f of x is the same as y. So f of x will be 5 times 1 squared minus 4 times 1 plus 3. And that simply means 5 minus 4 plus 3, which is 5 minus 4 is 1 plus 3, that's 4. Therefore, the coordinates of the point where the gradient is 6 are 1, x is 1 right here, and 4. Those are the coordinates of a point where the gradient is 6. I think I want to stop there and continue in a bit. Thank you very much, and I'll see you in a few minutes. Bye-bye.